Cool, we're recording.
Okay, Rob, I think you're on the call. If you're in, oh, okay. So there's some folks from Google. I think, yeah, we're good.
Cool. We're recording now. So this is the sig-network meeting for Thursday, October 17th. Why don't we start off with triage? Does anybody have that ready, or should I try to get that going?
Looks like Andrew has shared the link.
Yeah.
I can present, or you can present, Casey.
I'm happy to present, although the link didn't seem to work for me.
It seems to work if you copy and paste it, but if you click on it, it ends up getting mangled somehow. Probably a Zoom bug.
Right. Okay. Let me share this. And then copy this. Okay. Looks like we've got 5 to go through. So as usual, just looking for folks to volunteer to follow up on these so we can mark them as resolved or triaged or close them, depending on what the right outcome is. So it looks like Minhan's already assigned to this one. Have we gone through this one in the past? Is anybody on the call familiar with this one?
There was a working theory, and it's basically the API server. The API machinery does not handle the after reset. So that was the theory, but we don't have proof for that. It linked to another bug to the API machinery.
Right. Okay. So we're not fully convinced this is solely API machinery. Mm-hmm. Does it make sense to remove the sig-network tag from this?
Sorry, so we don't think this is our problem? I just walked in, sorry.
There's a linked bug by Liggett,
Okay.
and I think that can cause the controller to just don't react because there's no event.
And the linked bug is not a network-specific bug?
Not a network-specific bug. Yep.
Okay, so should we just close this as due then? We shouldn't leave this open if there's another bug.
But we don't have deterministic logs to show that it's the case.
So are we going to follow up on this, or are we just going to leave the bug open until FetaBot closes it?
So we can reproduce it. And
okay.
Yeah.
Sure. Yeah.
You reopen it if they somebody else sees it. Or
every time FetaBot closes a bug, it's a failure on our part.
Okay.
All right.
Like closed until repro.
Yeah, and like if somebody can reproduce this, please reopen it. There's just nothing actionable at this point. I have to leave it.
Okay. Closed. Next up. Oh wait, this one's with you.
No, Boy's not here.
No.
Boy's on the call. Oh, there it is.
I'll follow up. I haven't gotten to this.
Okay.
I am waiting on the user for this one. I think they might just be missing like the IPVS kernel modules.
Sounds good. I guess we'll check in on this one next time and close it if there's no response. This was assigned to me. Interesting. All right, yeah, I looked at this last time. I guess there's been no response.
Give him one more ping.
Yep. Who is this? Yeah, I'll come back to this one. There we go. Another one that's assigned to you, Bowie.
Yes, let me take a look at this. I think this might be KubeADM related. Let me take a look.
Cool. So that was all that showed up as untriaged.
All right.
Pretty cool. So next on the agenda was kube proxy performance improvements.
This is Rob Scott. Just wanted to, if I can share my screen actually, I wanted to share a bit about some performance improvements we made with kube proxy. And that's all related to endpoint slice. And at the end of this, I want to go through what we're proposing for endpoint slice beta in 1.17. Can everyone see this?
Yep.
Cool. All right. So as part of this performance testing, I wanted to make sure that kube proxy actually performed well with endpoint slice. The end result was performance improvements with endpoint slice and without endpoint slice. But generally what I did is I would spin up a cluster with kubetest. I'd modify the kube proxy manifest on at least one node to enable profiling. I'd use port forward and gotool pprof to profile kube proxy. And Minhan actually has this really cool bunch of helper scripts for Kubernetes called kubescript, which makes it super easy to push a custom build of kube proxy to a specific node. So I used that to push a few custom builds to different nodes. And those different builds ended up being original 1.16, 1.16 with slices enabled, and then new and new with slices enabled, in both cases being the performance improvements I got to. And the final results were gathered on a 150 node cluster over a 15-minute window, scaling from 0 to 10,000 endpoints. So we found 3 bottlenecks in this whole process and just want to cover what they were. The first 2 of them were very much me and endpoint slices. So for consistency, when comparing values, I was trying to sort endpoints just so that they would always be in the same order when comparing them. And I was comparing them by endpoint.ip. And that IP function call was not just returning a string, which I thought it was parsing a string out of an IP port combination using netutil, which was very slow and ended up taking 41% of total kube proxy CPU time when endpoint slices were enabled. So I just sorted on full string, just for equality, and that made a big difference. Bottleneck number 2, endpoint slice cache.endpoint map. So for those familiar with kube proxy, there's this data structure called endpoints map, and that makes it really straightforward for proxiers like IP tables or IPVS to translate that into actual proxy rules. That was fairly easy to convert from endpoints, but a bit more complicated from endpoint slices. And I had been following the same workflow that endpoints had, which was trying to convert every single time a new endpoint or endpoint slice came in, and that was very slow. So it ended up taking around 45% of total kube proxy CPU time after that previous fix. So the solution was to only compute endpoints map when proxiers actually require it, because the proxy sync run, so IP tables actually getting written to the computer is pretty rare, every few seconds, as compared to every single endpoint slice update can be very frequent. So just changing when that happened made another huge difference. And then the final change here was to change when we ran detect stale connections. This is something that affected every aspect of kubeproxy. Detect stale connections ends up being a very expensive function to run. And as far as I can tell, it's only really useful or used for UDP ports. And we were running it for every single connection. So if you had nothing but TCP ports in your workflow, it ended up taking a huge percentage of time that it didn't need to. So in this case, it was taking 81% of total kubeproxy CPU time, regardless of endpoint slices being enabled. And this is after the previous fixes were already in place.
And all this does is call contract to flush rules.
That's exactly, yeah. But the most expensive part is figuring out what those stale connections are. Yep. So with those results, again, highlighting this is watching a cluster scale from 0 to 10,000 endpoints. I have a 150 node Kubernetes cluster. I have 4 different versions of kubeproxy on different nodes. Those nodes have nothing else other than the very basic elements that you would expect on a Kubernetes node. And this is over a 15-minute pprof profiling window. So the first thing is kubeproxy memory util really didn't change that much. There's a bit of a change here. So if you can see this green line, that represents the newest version of an endpoint slice with some performance improvements. But these changes are small enough that I can't say for sure that it's actually a change and not just noise. But potentially some improvement here. Oh, okay. And then the next thing that was very dramatic was kubeproxy CPU utilization. And this bottom, these numbers represent the number of minutes into the testing. And you can see that my initial endpoint slice implementation was very CPU intensive and not very efficient. That is the yellow line that is taking several minutes longer and significantly more CPU time to complete. The dark blue, navy blue line is the original endpoints implementation in 1.16. And then the light blue line is the new endpoints implementation with these improvements. And the green line is now the most efficient implementation, which is endpoint slices. And if it's easier to visualize, pprof actually gives you a total CPU time that was used throughout this process. And this is what that looks like. So according to pprof, the total CPU time, you see this huge change from endpoint slice 1.16 down to endpoint slice new, almost comical. And if it's easier to visualize with numbers, those are the seconds of CPU time over that 15-minute window used by each implementation.
So
Rob?
I'm going to ask, why did you only stop at 3 optimizations? But if there's no more cliff, then
yeah, right. Yeah.
Rob, that's a serious amount of work, man.
Thank you.
Thank you.
Yeah.
Thank you.
Yeah, and I should note, like this is optimized for, like I intentionally tested with TCP connections. You're not going to see the huge performance improvements with UDP connections. So keep that in mind. Yeah, because
are there optimizations we can make in that?
I looked at it, they weren't as obvious. That's what I'll say. The biggest things that it was spending time on were map reads. And like it's just a really expensive thing. I hope there's optimizations because that's still taking a huge amount of time if you have UDP connections, but there was nothing really obvious that stuck out.
Any UDP connections, or if you have?
So it only will call that function for UDP connections. So yes, it'll slow down a bit if you have a couple, but it will slow down a lot if you have tons. Yeah.
So that function is essentially comparing the old endpoint backend set and the new one. If the set is different, calling the stale, like basically eliminate the stale connections by calling the contract. Maybe we can like
Keep some cache.
Yeah, maybe
Keep
make
an
it
index.
maybe make it hash or something so that make the comparison like less like ON instead of O1. Like
I mean, I feel like as we're processing ports, we know at that point if they're UDP or not. Like, couldn't we squirrel that away, memoize that somewhere, and say when it comes for detect stale, you say this is where the possible UDPs are. And
Yeah, so that's what this is doing. But yeah, we should still only cache something for those UDP values beyond that. Yeah. So there is certainly more that could be done here. But this should be good. Big improvements for 1.17.
Are these big changes? Like, why would we not port these changes to 116 something?
I mean, so what you notice, if you go back to some of these charts, you don't, so this doesn't really explain it very well, but I didn't really notice huge differences until you got into the thousands of endpoints. Okay. So for your average user, this is not going to be that noticeable. But when you do get into those thousands of endpoints, like this is 10,000, I've tested with 15, with 50, especially with 50,000, it's absurd, the difference. So, yeah.
But it also means that the overall control plane footprint on the cluster is smaller.
Yeah, especially for kubeproxy running on every single node, this will be a big change.
That's the win right there. No, I don't think it matters. A few people run a very large number of endpoints anyway, but a lot of people have this perspective of I need nodes bigger than so in order just to get my application to work.
Yeah.
Yeah, if these changes are not super egregious, I would consider that.
Okay. Yeah, all the PRs are merged so we can look at them. I don't think any of them were particularly huge. So
it looks like you're getting more than 20%.
Yeah.
Memory is sort of expected because kubeproxy is essentially caching the exact same amount of data. But the transport, one thing that did not measure in this test is the transport, the amount of data transport between master and each kubeproxy is probably significantly.
It is a huge difference, yeah.
So memory, because kubeproxy need to cache the global state on every single service and every single endpoint. So the memory is not huge, but the CPU and network.
Yeah.
And also the load on the master.
Yeah.
Cool.
Well, yeah. All right. Well, I'm going to move off into endpoint slice if there aren't any more questions. Cool. All right. So endpoint slice beta is hopefully.
Sorry, one more.
Yeah.
Are you going to publish those slides?
Yeah, I'll link that in the sig-network.
Yeah, throw them up on the speaker deck or something.
Yeah. That'd be cool. All right. So endpoint slice is going beta in 1.17. And as part of that, added some graduation criteria. I'm sure some of you saw the KEP PR that's been active for a bit and got merged in sometime this week. And here's what we committed to for graduating to beta in 1.17. The first one was already in there. It was kubeproxy switch to consume endpoint slice API. That's already done in alpha. We just want to turn that on to be enabled by default. Again, verify performance and scalability via testing. I've scale tested this a bunch at this point, including 50,000 endpoints on a 4,000 node cluster, and that actually worked fine after these improvements. Actually, one little note, I didn't mention this earlier, using IP tables specifically, the probability that we were using started to repeat itself after 319 because we only had 5 decimal point values or whatever. So I increased that to 10, and now we can go to 100,000 plus endpoints without repeating that. So
that's a great bug. Thank you.
Yeah. Then those performance fixes, there's 3 PRs. They're all merged in at this point. Cal has graciously volunteered to do a dual stack integration for endpoint slice support in kubeproxy. But I can certainly help out with that as well. And then the second bit, these are where we started to get into new things. Certainly, we want to make sure that E2E tests cover both endpoints and endpoint slices. We get a lot of that for free, but we want to make sure that when we turn on endpoint slices and all the existing tests that will cover that, we also want to make sure they cover endpoints so we have full backwards compatibility and we know that both continue to work for the foreseeable future. Then there's 3 additions, and they're all really related here. They're related to the idea that we want endpoint slices to be useful for more than just our own endpoint slice controller and kubeproxy use cases. We want other things to be able to manage these, write to these, and use them for whatever is useful for them. So this label name is very much still up for debate. Certainly comment on this PR. But there's a endpointslice.kubernetes.io/managed by is the current proposal that would basically say this is the controller or entity that is responsible for this endpoint slice. Then we're adding a FQDN address type to just support more uses of endpoint slice. And finally, a requested feature add support for optional app protocol field on endpoint port. As I understand it, I think this has been talked about in other APIs before. And we're trying to make endpoint slice as usable as possible. And it felt like a good place to fit this in. So any questions on any of those?
For the managed by, there's something in API machinery, the server-side apply, and it's got this concept of different sections of the resource being owned or modified by different actors.
Okay.
And so we want to make sure it's consistent.
Okay.
I don't know what terminology they're using for that.
Okay.
But that's for just one single object, right? Like
Right.
Yeah. So this is
with just terminology. I would think you'd want to see this.
Concept-wise, I think we can find alignment. I don't think it's the same problem.
Okay.
No, it's not the same time. We still need this.
I need to step out. Thank
Cool.
you.
Thanks.
Rob, the controller, I remember, was fragmenting. If a lot of endpoints were deleted at some point, it takes time for it to recover. I remember we had this discussion and we agreed that it's a later discussion. Maybe we should look into that as part of the beta criteria.
I see. So I think that discussion is in the PR review during alpha. So yes, I agree. Now it has a problem of fragmentation when you have, let's say you scale up your service and you scale down significantly, because we don't do active balancing. So meaning that we don't move one endpoint from one endpoint slice to another. So let's say you scale down and then you have one endpoint in the whole slice. That slice end up like basically living there. So what we plan to address is that by instrument this exact behavior is basically how many desired endpoint slice we want and how many is like actual number of endpoint slice we have, and then we expose that as like metrics and see like how bad was it, and then like what's the impact, and then evaluate on like what's the later on algorithm to move forward.
So that sounds fair to me. So you want to do the utilization, the slice utilization metric?
Yes.
All right. And I'm assuming that worst case scenario, if I'm running this and I end up with 1,000 endpoint slice with 1% utilization, I can just a script delete all the endpoint slices and at least the new one should be created compacted because that's the default behavior.
Yes. Yes.
All right. I personally think it's fair enough for now. All right. And as we evolve, this can be addressed based on what we see.
That was good.
And on that note, there is another PR that I didn't mention here that actually adds those metrics, and I can link to that in the agenda after this.
Thank you.
Awesome. Thanks, Rob.
Thanks.
Next on the agenda was from Dan Williams, but I think he's actually not on the call today. So I suspect we should move that to next time. And then the last thing on the agenda is dual stack multiple node CIDR masks.
Hey, yeah. So I have a PR open for that, and there's been some discussion going on. Tim and Andrew have reviewed it and added some comments basically on the design. The way I initially implemented it is basically have the node CIDR mask sizes as comma separated values, similar to cluster CIDRs, and there would be a one-to-one mapping. But I think what Tim was suggesting on the PR is we have a separate flag for IPv4 and IPv6, and the user would be able to do that. And the thing is, we keep that and the existing node CIDR mask size flag mutually exclusive. So if it's a single stack cluster, then they would just use the one flag. But if it's dual stack, they would use the IPv4, IPv6 flag. So basically, I added the PR link here, and I just wanted to see what the consensus is, and so that based on that, I can make the change. And this is to have different CIDR masks for IPv4 and IPv6 CIDRs.
Does anybody have an opinion on that that split? Seems like not. So is the ask that additional folks come in and review this PR, or do you feel like you have the review that you need?
Yeah, I mean, like right now, from the PR, it does look like a lot of folks are on board to keep it mutually exclusive. So if they did mention the other flag and dual stack, then error out. And that's the kind of direction that I'm looking forward to go through. And I mean, I don't see any objections on this call, so. So yeah.
All right.
Is somebody trying to talk, and we're not hearing it because it's too low, or just a background noise? Oh, background.
Yeah, I think that was probably just background noise. Okay. In that case, I guess carry on with what you're doing in the PR. Doesn't sound like there are any strong opinions here.
Yeah. Thank you.
Thank you. That was the last item on the agenda. Is there anything else that folks wanted to talk about? All right, then we all get almost half an hour back. See you all in a couple weeks.
Bye, everybody.